Hello there, Math 1B. I've got a new video to start off semester 2 of Math 1B. We're going to be talking about the very same thing that we dealt with at the tail end of semester 1, simply because that chapter really wasn't complete yet. But of course, the COVID learning kind of slowed us down a bit. So, instead of going through that entire chapter again, I figure if we can catch on to this simple factor by grouping lesson again, I think you guys will be set to move on. So, without further ado, what is factor by grouping? Well, factor by grouping was this idea that if we have four terms of a polynomial that don't seem to share anything, but their pairs seem to share, then what we can do is we can regroup them as x cubed plus 7x squared and regroup these as plus 2x plus 14. If we can find a common factor of each group and then come out with identical twins at the tail end, we can factor it by grouping. So here's what I mean. X to the third and x to the squared both share two x's. Okay? So what we do is we say divide out an x squared here, divide out an x squared there. That's going to be the greatest common factor that goes on the outside of parentheses. So we have divided out or factored out an x squared from this group. So the leftovers that remain inside these parentheses are x cubed over x squared is just 1x. And then the x squared divided by x squared here completely cancel out, so you're left with a plus 7. Now when you take a look at our purple group, 2 and 14 are both even, so you can factor out a positive 2. But that's all you can factor out. So I'm taking a plus 2. I'm dividing it out of just these two terms. And remember, that should leave us with an identical term to what we got in the previous linear pair. So 2 divided by 2 is 1x. 14 divided by 2 is a positive 7, and there you go. X plus 7, those are identical terms, which now allows us to do that last step where we say these two terms become 1, the two leftover groups become 1, and the two GCFs that we had, x squared plus 2, they become their own group. Now, if you've forgotten, by the way, that's it. It's factored now. If you've forgotten why this weird last move works, think about the previous chapter to factoring. Okay? The previous chapter to factoring stated, if I have x squared plus 2 times x plus 7, and they told me to expand the polynomial, the way I would do that is I would say, I'm taking x squared times x plus 7. And I'm taking a positive 2 also times x plus 7. Beyond that, you would multiply the x squared through. You'd multiply the 2 through. Now notice, that was the original polynomial. I checked it out. Our factoring was legit. So I guess what I'm trying to say is the reason why we can go from this step to the final factored version of that is the way in which the reverse multiplication works. In order to multiply out x squared plus 2 times x plus 7, this breakaway where you've got identical twins is the same structure as when you're factoring by grouping. So, you don't have to do this every time. I'm just trying to show you that you have a mechanism for checking to see that this is correct. You multiply it back out, you should get the original when you do so. All right, number 1, complete. This is our final answer. This was just me explaining. Okay, number 2. We group the first two together, and we ask ourselves, what do 3x squared and xy share? They share an x. And it looks like it's a positive x. So a positive x on the outside, 3x squared divided by x. One of the x's on top cancels, which leaves us with 3x. X divided by x gone, but you're left with a y. Second group. I'm noticing that there's both positive numbers inside here. 3x plus y. We need the inside to be all positive. So if there's two negatives here, I'm going to divide that negative out. Divided by a negative, divided by a negative. Now I also notice that 4 goes into both 12 and 4. So divide out negative 4. And what do we get? Negative 12 divided by negative 4 is positive 3. And that x is still there. Hey, it's looking good so far. Negative 4 divided by negative 4 is a positive. And then the y is left over. Okay, so identical twins is what we must have. And those identical twins then become the GCFs that you took out, x minus 4, become one group. Remember, we're doing the reverse of polynomial multiplication. So you got that x minus 4, and then the two leftovers become 1. And then you're done. If you're feeling a bit confident right now, try number 3 on your own. Pause the video. Okay, let's see if you're correct. So 6x squared minus 3x minus 2x plus 1. If we group the first two together, we can divide out both an x and a 3. So the 3x goes on the outside. Inside parentheses, you're left with 6 divided by 3 is 2. X squared divided by x is 1x. 3x divided by 3x is 1. There's only one negative, so it's going to stay negative. Second group. Keep in mind, you're trying to get out of this the same leftovers. So if you think about it, how in the world am I going to get positive 2x minus 1 from negative 2x plus 1? You divide out a negative. If I divide by a negative, it changes the signs. And I need to associate a number. I can't just divide by the negative. It's got to be negative 1. So the negative 1 is the GCF that you take out to create a 2x minus 1. 3x minus 1 becomes its own group. And 2x minus 1 becomes the second group. All right. Last one, number 4, looks interesting. I'm noticing, sometimes it's best to move terms around when you can see better matches with linear pairs. I think we're okay because these both share an 8 and an x squared, so I'm going to leave it. All right, first group, I can divide out an x squared for sure. But I can also throw an 8. 8 goes into 16 twice. So the 8x squared goes on the outside. 8 divided by 8 is 1. X squared divided by x squared is 1, but there's a y. 16 divided by 8 is 2. X squared divided by x squared divides out. So it's going to be, that minus is still there, y minus 2. So keep in mind, we now are requiring a y minus 2 to be the leftovers for the second group. Once we establish that this has to be y minus 2, that also must be y minus 2. So it's easier that way to actually find the GCF for the second group once you, recognize that you are restricted to doing just that. Yeah, so I'm looking at the negative 4x right away and saying, negative 4x, I got to divide out the x, which fortunately there's an x there. and I got to divide by 2 to get that 2. Same thing there. And the question is, do I divide out a positive 2x or a negative 2x? Well, right now we got a plus minus, which is what we had before. So I'm going to take it out, just divide by positive. So divide by positive 2x. That should give us y minus 2. So then x squared plus 2x become 1. Y minus 2's, those become 1. Now, I taught you guys this, I think it was the very last lesson for factor by grouping. Notice, 8x squared plus 2x, they both have a GCF that I never took out, which when you go back to the original statement, you'll notice, hey, everybody's even. So technically I could have divided everybody by 2. I could factor a 2 out. And everybody's got at least one x. X squared y, x squared, xy, 4x. I could have factored out a 2x at the very beginning. So you need to factor that 2x out now at the end because you failed to do it at the beginning. Or I failed to do it at the beginning. So what does that look like? Well, that's me saying this is still not completely factored. 8x plus 2x, still not factored completely. So I'm going to divide out the 2 and the x. And all I'm going to do is I'm going to put the 2x outside the parentheses. Inside the parentheses, I'm going to divide out the 2x's like I've been doing this whole time. It's going to be 4x plus, and then anything divided by itself is 1. And the y minus 2 is still attached to the tail end. So this is technically the final factored version of what it should be. Not that. Still not factored completely. So I know that'll be a challenge for us because we like to be done as quickly as possible with these problems. Just make sure you guys are checking those so that you recognize fully what it means to be completely factored. All right. Thanks for taking 13 minutes out of your day to watch the video. Hopefully you guys found this helpful and a nice refresher to what we talked about at the end of semester 1.